My name is Colin Rotten. I'm also a postbac in classes in transportation planning.
Nelsa Victor, graduate student in structural engineering.
Matthew Rohrbach, first year graduate student in the Urban Regional Planning Program.
Levi Roberts, same as him.
My name is Nick. I'm a first year graduate student in the Urban Planning Program as well.
In the same bag, doing land use.
Name?
Dave West, second.
Thanks.
I'm Brian Handgartner, first year grad student in civil and environmental engineering and transportation.
Jenna Padilla, I'm a faculty in urban studies and planning.
James Tyree, I'm a certified permaculture designer and here to learn more about transportation.
I am Song Moon, a graduate student in urban studies. I'm Won Chen, in transportation certificate program.
My name is Young Lee. I'm a computer science graduate student.
My name is Tessa Walker. I'm a grad student in urban studies.
My name is Steve Leathers. I'm visiting from the University of Pennsylvania, and this looked interesting.
I'm Ashley Hare. I'm faculty in civil engineering.
My name is Chris. I'm an undergrad in environmental studies.
My name is Brandon Conway. I'm postbac and trying to decide if I want to do the urban studies program.
Well,
Is your mic?
yes, it's on.
Okay. All right, so let's, I'll now do the formal introduction. All right.
Good.
So welcome to the Friday Transportation Seminar at Portland State University. My name is Chris Monsieur. I'm a faculty member in the Civil and Environmental Engineering Department. And together with my colleagues in the transportation area, we co-organized this Friday Transportation Seminar. We're very pleased today to have Lech Muszynski to present today on Bio-Composites for West Coast highways. He's from Oregon State University, one of our collaborators in the Oregon Transportation Research and Education Consortium.
Thank you, Chris. Thank you very much. Thank you all for coming. I hope I won't disappoint you. I mean, I'm not going to educate you about transportation, right? That's your specialty. I'm coming from the Department of Wood Science and Engineering, and that's my background, essentially. So it's like very specialized material science focused on natural biocomposites, right? This is what we do. And I would like to present you with a project that has just started. I mean, so there won't be much of results in here, more like the justification for the project, the idea itself, and I would love to hear from you at the end of this presentation. What do you think about it? Because this is for many of us in wood science and engineering, first time coming out of the shell to a little larger world. We have a history of being quite insular, right? And see greater consequences of what we do, right? Let me recognize the collaborators and co-authors on this project. My graduate student is Michael Karas. I have collaborators on this very project from faculty side. That would be Chris Knowles and Eric Hansen from the marketing side of wood science and engineering. Kevin Boston is a professor in forestry in our college. And then their graduate student is Derek Thompson, who did some marketing study or is in the course of doing a marketing study in this area. And we have a visiting Fulbright fellow from India, Siddhartha Sethi, who has brought very interesting insight to this problem. So let me start with this. What we hope to do, what we aim to do, is to seek for sustainable opportunities to make Oregon or West Coast highways a little greener, make healthier forests and healthier communities around, right? That's lofty objective. Now, the broader context, I used to be shy about showing this. I used to assume that, well, everybody is familiar with this, but you would be surprised how many people react to this. Oh, so I gather that I don't need to elaborate on this slide, right? I'll just go further. I mean, Oregon is one of the pioneering states in this area, so we don't have anything to be shy about. And this is how in 2001, in this Oregon Sustainability Act, the sustainability has been defined, right? And I would like to draw your attention that the perspective of the context of this sustainability has the implications for not only for the environment but for economy and the community objectives as well, right? So this was something that we found ourselves tackling while working on materials, right? And it's got increasingly interesting. Let me start. Okay, what do people with forestry or wood science background do with this? Let's start from how we see the problem, or how we originally saw the problem, right? There are many reasons for removing woody biomass from the forest floor. And this is in part, I mean, doesn't the Mother Nature take care of this on her own? I mean, there are these forest fires that should happen periodically, right, before even humans arrived to this place, right? And then it would take care of this. And then there are these little fungi that decompose it and so on, right? So we essentially we shouldn't mess with this, right? But the fact is, humans are here in this area for 15,000 years, right? They have been doing their stuff. They have been actually managing this quite well. But for the past 100 years, this entire process has been disrupted. I mean, the forest fires have been suppressed, and then there is a buildup of forest fuel on the forest floor, right? Because it has not been systematically burned off. And this is an increasing problem. I mean, you all hear about catastrophic forest fires. These are not just the fires that cleans the forest floor, right? But these are forest fires that destroy the entire forests with all animals in there, with communities around them, right? So there are good reasons for removing this. And there is not only the stuff that is clogging the forest floor, but there are so-called forest ladders, smaller trees or dead smaller trees that essentially help the fire to get to the crowns of the larger trees that are supposed to survive these regular fires that were here before humans arrived, right? Now, that's a problem. That's one of the reasons. And the fact is that particularly in this region, right, we are in a region that is plagued by devastating forest fires because of this disruption, okay? The recommended measures, and this touches both the public owners of the land and private owners of the land, is to thin the forests, to remove this excessive small underbrush, and to thin the overly dense forests. And according to Oregon Forest Resources Institute, in Oregon alone, and you can extrapolate it to the other states of the West Coast, there are about 4 million acres of forest land that need to be treated that way or are treated that way, right? So this is a substantial operation going on, and it was easy and easier to fund when there was regular logging operation. Now in this crisis, right, where the logging has virtually stopped, this operation has to go on anyway, right? So it's like sheer cost to the owners meaning to the private owners and to the public, right? This is where we are. Now, currently, most of the biomass generated in this costly operation is being burned on place. There's not much use for it, right? Well, there is some. I'll go to this later. So this is the major problem on the eastern side of Cascades, right? On in the dry forest. But there are good reasons for thinning the commercially logged forests on the western side, right? The wet forests. I mean, this improves the forest health. It adds value to the standing logs that are going to be harvested, that are scheduled to be harvested somewhere down the road. So it is going on the forests that are not in danger to be burned as well, right? And then again, even in the time where there is not much of harvesting, this operation has to go on, okay? And it's cost. And then there are post-harvesting treatments that also involve gathering together the biomass. And burning it on place, right? Not very good thing. Now, to be honest, I mean, this is something that has surprised me, and even living with foresters in the same building, right? I've discovered it quite recently. I mean, it's not, I mean, controversies about it are everywhere, right? While removing the biomass has very clear benefits, right? In many ways. One example of this would be just removing forest fuel, right? There are people who say, well, you should leave this biomass over there to rot and provide nutrients to the next generation of forests, the next generation of trees, right? So it is a controversial issue, and this is just to acknowledge this. Now, these logging operations are not the only sources of woody biomass. There is urban waste generated by demolition, right? Or the urban green maintenance and so on, right? Demolition would be the major source of woody biomass. So that's another thing. And then there is commercial fiber. However, this is taken care of. Forest product industry became in recent years very efficient in recycling, reusing the waste it generates. So essentially, on the balance, on the bottom line, there are zero waste industry, right? Very nice thing. And there is, of course, agricultural waste that could be thought of in the same way. It's being generated in great numbers, right? This would be like corn husks or something. So there's lots of biomass being generated and wasted or burned, right? Which is, some argue that burning wood for energy or burning it on place is carbon neutral because this is the same carbon that has been sequestered by the forest, right? But still it would be nicer if we can do something with it. And you can see that actually the agricultural waste, the biomass generated by the agricultural waste, right, is much a bigger problem by volume, right? But we keep it on the back of our minds. We are from wood science department. I mean, we don't care about it right now. Although in the past, forest product industry has been a model for many things that happened with utilization of agricultural waste. So it's just good to remember about it. Now, there are, of course, there are costs, right? Do you need this? No. Of course, there are costs related with utilization of this thing, right? Even if you burn it on place, you still incur cost of felling these little trees, right? Of thinning, and you incur the cost of extraction of this from the forest floor and putting this on one place to burn. So these are costs already borne by the forest owners, right? And then if you want to get it anywhere, you need to, how to say, reduce it, right, or comminute it to smaller grade, because you don't see trucks carrying the branches, and this is for a reason. It's a very inefficient way of moving the biomass, right? You need to reduce it on place so that to densify, so to speak, the load, right? And then this transport itself. So while burning of the biomass for energy is becoming, and particularly when gasoline was 4 something per gallon, right, has become a very, very hot topic, the economy of burning the biomass for energy has some limitations. You can deliver it only that far from the source before you burn more fuel actually to deliver it than you can get energy from this biomass. There is there is continuous research on the lignocellulosic biofuels, right? This is how this biomass could be converted once we know how to do it efficiently, right? Which we don't at this point. And then some of them can be converted to mulch, animal bedding, whatever, right? So these are the current uses. The question is, are there other reasonable uses for this biomass generated in this entire process? Can we use it in a sustainable way? hopefully avoiding burning this stuff, therefore arresting the carbon dioxide for longer, providing more sustainable use for it that would not come and go with the prices of gasoline, right, and energy, and it would benefit us in somehow, right? So the potential for offsetting the cost of the operation would be if we find, as I said, innovative technologies and uses for this raw material, hopefully in value-added products, right? That would potentially generate a demand for this biomass. And needs to take into account that there needs to be a sustainable use of all grades of this stuff. And this stuff, as you see, it's messy, it's dirty, it's lots of bark, it's not just clean wood, right? It's not clean biomass. So that's the challenge. There are some social impacts to this. Remember when we defined the sustainability, right? There was this commercial side, economic side to this. There was ecological side to this. We've been banging the ecological side to this. I mean, the reasons why we are doing this and what is the impact on forest health and so on. But there is also social impacts. Here in Northwest, many communities historically have been created and developed around forest products industries, right? So with this, with things that are going on since 80s here in Oregon and Washington State, right? Many of these communities have been losing their ground gradually, and this economic crisis actually put them on the brink. So one of the potential benefits would be reviving the economies of these rural regions if we can organize them, or if we can get them something to do with this biomass, right? Do something useful with it and keep them busy with the stuff that they can do, that they know about, right? Forest products. Okay, how can we utilize this very fuzzy, this very low-grade material? You cannot cut it into logs. You cannot utilize it as pulp. It's too dirty, right? As pulp for paper. You cannot. I mean, but there is a way of utilizing very low, fine grade of wood. This is like wood flour, right? Wood shavings, and these are wood plastic composites. These are heterogeneous composites made of three phases, essentially, wood, some kind of thermoplastic composite. The most popular is high-density polyethylene, and some additives, right? So we are working right now. I mean, this is still petroleum-based plastic, right? HDPE, but projects are in work at Oregon State to replace it with biopolymers, right, which would increase the greenness of this thing. So you would have biomass as a filler and biomass in the matrix. The additives, up to 10%, they can modify the properties of it, right? So you can plastify it, you can make more flexible, you can make it more rigid, you can add color to it, you can do many things to it, right? The manufacturing process is relatively simple, and this is why it seems so attractive. It's not a major investment. You don't have to build, like, even cogeneration plant, right? Building cogeneration plant is much more expensive than this little extruder, which is essentially a mixer that mixes together the biomass, the wood flour, right, with the polymer at elevated temperature. And then you can do, at the output, you can either extrude a profile, right, or injection mold a complex part, or pressure mold something. So it's a very versatile tool, and it's nothing different from what people in plastics industry are doing anyways, right? And they are widely accepted as a replacement for virgin plastics, right? Which means if I add just 10% of biomass, I'm phasing out 10% of petroleum-based plastics. If I add 30%, and so on and so forth, right? And in some non-structural applications, they have the potential of replacing concrete, aluminum, non-structural, etc. Now, this would be an example, right, of products that can be made of wood plastics. I'm always amazed why this is made in China, not in here, right? Do they have this biomass? No. fears the biomass, right? But they're getting good at it, and there is no reason that there are people who are getting good at it here in the United States, in Europe, right? It is a way of making quality products. In your cars, can you still remember the metal dashboards? I can't, right? These are wood plastic or bioplastic composites, right? Right now. You may not see it, but they are around. And it seems like the ideal solution, well, not ideal, but close to ideal solution, right? It serves a couple of things. I mean, it makes the forest healthier, it makes the Oregon greener by arresting lots of the biomass, lots of the carbon in products. It's replacing petroleum-based plastics in products, right? Phasing it out. It seems to be fostering, if we are successful, right? Fostering the transfer of the Oregon forest products from large facilities to smaller and productions, but high tech, right? Which advances a little bit the state of the art. Rural development, potential job creation, right? Looks very nice. Healthier, more sustainable state economy. Can we do it though, right? Can we do it with the, and the issues, I mean, it is fair to say that at current, although there is research to make these products into structural materials, the state of the art is that there are not structural materials, right? There is significant creep related to this, there is thermal expansion, questionable durability, although we made great progress in it, and weight to strength when compared to it does not seem very attractive. These are examples of current research that are underway that aim at improving the wood plastics. But what does it have to do with Oregon highways, right? We are not getting there. We don't seem to get there. Now, currently, these wood plastics are being made with high-quality wood, right? The question is, if I have this messy material, can I still make quality products? And the answer is, well, it depends. What do you mean by quality product? It depends where do you try to push the envelope for the quality, right? Is it just sheer strength and you want the structural capacity, or do you want something else? Are there any other products that have the critical properties somewhere else? And then I couldn't help to notice, as you pass along the highways, you see lots of plastic products that do not seem to be very demanding, right? You pass mileage posts, you pass traffic counts, traffic barrels, right? They're all made of plastics. If you go, there may be miles and miles of this product. Some of them small and not sophisticated, some of them large and sophisticated and quite structural, quite demanding. And if you just think about the highway system, right, multiplied by the mileage just of the major highways, it seems that there would be a quite large output, right, outlet for this kind of products if we try to think about it. So this is also an area where the use of materials is increasing. Well, it's fair to say this is mostly pavement, bridges, and so on. Do I propose to make pavement out of wood plastics? No. Do I propose to make bridges out of wood plastics? No. I would be actually very, very anxious if I saw anybody proposing this, right? These are not good materials for bridges, right? I wouldn't like to drive on bridges like this, right? All that alone, right, is responsible for 19,000 lane miles, and this is just 9% of the state's total. So if this is just to give you the sense of scale, right? What you can do with things that may sit here, like the dot bots, right, or bot dots, or whatever they call this little reflectors, right? They sit essentially at every little strip like this, right? So you just multiply the small thing times miles and miles and miles, and this is just the review, not complete, right? I admit. Of products that could be thought of, right? Starting with the traffic cones, drums, barrels, channelizers, work zone barricades, water-filled traffic dividers, manhole guards, manhole protecting rings, signposts, snow fences, right? It's all highway related products that are currently being made mostly of plastic, of metal or concrete, while they don't have to be made that way, right? These are materials of of rather large carbon footprint. There are also the high-end roadside hardware, right? Those that have to be carefully engineered, like these collision barriers, guardrails, right? So there is like entire hierarchy from things that are very unsophisticated, simple, and with very little, how to say, requirements for properties, to some that are essentially scrutinized very carefully, regulated, and okay, think about it that way. These numbers that you see here, that would be like volumetric percentage, right, of biomass in products. The state of the art is most of these products are made just of pure plastics, sometimes with some mineral fillers, right, with glass fiber fillers or something. So if you use just 20% of biomass by weight, that would translate into about 35% by volume, because the biomass is less dense than plastic, right? And that's a little change. This amount does not change the properties of the plastic that much, right? That would be just, even if it does not help, right, it wouldn't have much impact, and you are utilizing, you are phasing out about 20% of the plastic in all of those, or most of those. In some applications, you can go higher, right, and it still wouldn't hurt, 40%, right? In some, to extreme, you can go like to 60%, and these are actually those profiles that I've shown you, right, made in China. Those would be mostly 60% biomass by weight, and still very robust products, very robust material, right? So there's the potential. Now, the beauty of it is the large variety of products, which means there does not have to be just one centralized manufacturer, right? You can actually disperse this entire manufacturing to small mom and pop shops across the state, and match this, the diffusion of the manufacturing process would match the diffusion of or the dispersity of the biomass as it is. So it's shortening, its potential for shortening the travel time from the forest floor, right? It does not have to travel to the cogeneration plant somewhere centralized. It could be to the next small township, right? They are being used in large volumes. Even the smallest details, right, are being used in large volumes. So it's a model for kind of viable business. And it seems to address simultaneously a set of issues within the public agencies, that public, the within is incorrectly here. Public agencies are responsible for, right? Now, the same public entities are responsible for making the forest safer, right? The same entity is responsible for caring about local jobs, and the same entity essentially is maintaining local highways, right? So they are in position to considering the bottom line of this, not only based on the price of the product, right, but balancing with other costs that they carry anyway, right? So it seemed to fit this thing that I've been showing you before, right, quite nicely. Well, that's just the concept, right? We've got two projects going on that are aimed at assessing the viability of this concept. So this is how early we are, and we are early in the project of assessing viability. So if you ask me today, so is it going to work? I'll say, I don't know. I have reasons to be optimistic about it, right? I like the concept, and I would very like it to work, but it is going to take some time and effort to establish it for sure. right? So the objectives of this project are to determine an efficient methodology and criteria for assessing the viability, right? Now, how do you quite do it, right? It's just the bottom line, the price of this. How do you assess the benefits for the community? How do you assess and so on and so forth? Now, determine the material and performance requirements that can, whether this material and performance requirements can be met with these materials, right? Using this very dirty biomass. And conduct a case study to demonstrate biomass replacement on a selected roadside hardware product will actually work, right? Collaborate with industry to do it. Where are we in this process? Early. And there are plenty of questions. I'm not going to torture you with this, but this is, I mean, as we go, right? At first, this entire issue looked quite easy. We thought we will sit comfortably on our material science base, right? Mike Karas is a material science student. I'm wood science and engineering faculty. So we thought, oh, we can figure it out, right? As we go, the questions mount, right? And they are getting more and more involved and sophisticated. We reach out for help to friends in forestry, to friends in ODOT, to friends in many funny places, right? To try to answer a host of mounting questions, right? We can go back to these questions if you wish in the questions and answers part of this meeting. Now, speaking about viability, the evaluation criteria, there will be first the technological criteria. I mean, are the currently used processes adaptable enough to just substitute the fillers being currently used with biomass and without change of, it's possible, right, of technology? Or can you adapt the technology just slightly? Or is the currently used technology prohibitive in some way, right? So that would be first thing. This functional would be, okay, once you have this technology, you can make the profile. It looks the same, right? Does it perform? Would it perform that way? Would it meet the standard requirements? And then assessing the synergistic benefits. I mean, okay, we've got the part that works, right? And let's say it takes enlarging the cross-section a little bit to make it work just as well as neat plastic. And then at the end, you realize, okay, I'm using for this enlarged, more robust cross-section, right? I'm using exactly the same amount of plastic that I would use without the biomass, right? And I'm adding to the process, I'm adding costs, and does it add to the bottom line? I mean, is the benefit there, right? So, am I really creating jobs? Am I adding to the economy? Is Oregon benefiting from this at all, right? So this also needs to be included in, and this is the most challenging part. I don't have to tell you, right? Okay, so part one of this economic feasibility. This is a graduate student of Eric and Chris, Derek Thompson, and he conducted a short study. I mean, given the funny amount of money that we were funded with, and it's a limited study, but it's nice. I like it. There were two objectives: to determine the potential market size for this for 3 wood plastic composite products to be used on the road, right? Just 3, as a showcase, right? To see how the entire math adds up, and determine the sector perceptions regarding wood plastic composite. I mean, will they even consider doing this, right? Or will they say, no. So this is an illustration. I borrowed these slides from Derek. This is what it amounts to. Looking at currently used products, Derek has tried to assess the volume of the current volume of the market, and then looking at wood plastics, turned to the current, not really manufacturers, but the people who acquire this, so contractors and DOTs, and see what they think about this entire idea. These are the test products, right? Tubular marker. They have been deliberately selected. I mean, they're all relatively small, right? So it takes a scale in numbers to amount to something that can make a dent, right, in this entire problem. And this is temporary feature, right? So that's something that you put on place and then remove and put in another place. It's a different type, right? There's different math to it. Then there are these inert reflectors. These are nice because the numbers being used are essentially driven by a formula. You have to have so many of them per mile on roads of specific class, right? More in urban environment, less in rural, right? So you can relatively easy assess the scale of this. And then the guardrail post. These are things that have high performance requirements, right? They are ubiquitous, but you won't find many of them in urban areas, more rural features. So these three, right? Now, the public sector survey. It was carried on only in 3 coastal states. Only in public works and departments and DOTs in the cities larger than 50,000 inhabitants. To be very few in Oregon to find the right. And in California, only 10% of these departments were surveyed. And based on the population, then the results have been extrapolated, right? So these are the estimates of amount of plastic, volume of plastic, right, being used for these 3 products by DOTs in these 3 states and by public work departments, right? They amount altogether to 3,000 cubic meters. Does not sound like much, right? Now, the private sector survey was conducted with contractors in 8 Western states, right? Try to Google out Western states. I mean, I'm a foreigner in this country, right? So I was thinking Western states, would this be like this 3 coastal, this 7, right? Where 7 is quite often quoted, but then when you look, okay, Montana, that would be 8. That would essentially call for adding another strip in here, right? Wyoming and stuff like this. Nevertheless, the response rate was just 8%, but I'm being told it's normal. It's still successful, right? If you get this kind of response rate. And the contractor surveyed represented about 13.4% of the highway and road construction employees nationwide, right? Well, that's quite representative, right? Okay. Total materials suitable for substitution, judging by the contractor's estimates, would be about 5,000 cubic meters. Not much again, right? But keep in mind, these are just 3 small items, right? Remember the list of potential items that I have shown you? So you can multiply it times, and some of them, like the sound barriers, would be massive usage, right, of those. Okay. Let's see. Here is how Derek extrapolated this thing to the nationwide, right, based on the percentage of the surveyed entities versus nationwide. So there will be a potential for replacing 36,000 of cubic meters, right? So you can essentially extrapolate it to about 36 tons, right, of plastic. Well, not replacing totally. We are speaking 10, 20, 50, 60%, right? And about 33,000 judging by private contractors. So total of about 80,000 cubic meters just for these 3 test products, right? Okay, so perhaps it's worth thinking about. Objective 2 is measure the perception of WPCs. What Derek found was that in terms of familiarity, their perception of properties, their perception of sustainability rating, and important attributes in new products, they are not particularly familiar with what wood plastic represents. They tend to overestimate the properties. They tend to overestimate many things. They have great expectations. And they tend to think they would need to look at their bottom line. So unless there are state policies or nationwide policies in state, they are not going to be very excited about it. And products, whatever they are, have to make the DOT approved product list, which we agree on. I mean, absolutely, it has to happen. Okay, now the technical feasibility study. Again, we are at early stages, so you don't need to look anxiously at your watches. It's going to be a very short thing. The technical feasibility needs to be considered not even product by product, because these products are fairly complex. Even these little bot dots, right? They have 2 layers to them. So you can think of different properties being required from the top layer, different requirements being. So you have to consider this component by component, right? So this is a decision. I did something to. I hope it's going to look okay. It's going back one version of PowerPoint, so it's playing tricks on us, I see. Nevertheless, this is the decision algorithm that Michael has put together. And as I said, it goes material by material. Component by component. The first important decision is this part being made of plastic currently? And look easy, right? Because you are using the same technology to produce wood plastics. If they aren't, you need to evaluate the possibility of changing the technology, changing the material, right? Is it feasible at all? Now, going further, you need to assess if the addition of the biofiller does something to the properties that may actually invalidate them from the use, right? This is on the material level, not product level yet, right? We'll touch on what it means a little later. If not, you need to think of changing the technology of manufacturing this at all, right? Then if they pass this criterion, right, you evaluate the actual benefits. There you would be only in position to assess the total cost of this replacement, the environmental impacts, and whether any jobs are going to be created, right? If there are no benefits, you don't go any further. If there are, you're in good position for a substitution. And of course, if you see potential for changing the technology, this would be as easy as thinking of, okay, you have these traffic dividers made of concrete, right? Well, there are some that are being made of plastic and filled with water instead, right? Same function, same shape, different material, different technology. It works, right? Same thinking may be employed in here. The product requirements would very much depend where the products are being placed, and like zoning depending on how much likely you are to hit this little thing, right? And the crash-worthiness of this is very different. The crash-worthiness of the guardrail would be something different than crash-worthiness of the milepost, right? The guardrail is supposed to put you back on the line, right? Has to sustain the crash. The mileage post is not supposed to make any damage to your car, right? Both of them are deemed crash-worthy, right? If they feel so. Here you go. Now, the material requirements on certain level, all of them have certain things in common, right? Nearly all of them are in contact with ground. Nearly all of them have to sustain the large exposure to wide range of temperatures, the moisture exposure, UV. Many of them have to sustain the impact or abrasion and wear, like these pads, right? I selected a pad that has been exposed for some time, and you see that the UV did something to it. It's not bright yellow, right, as you see in here. So even the existing materials are yielding to the environment, right? So we shouldn't be shy with our materials. And then this is the thing that we've touched on slightly. I mean, if this is the tolerance for the material property, adding biomass, right, may degrade or may improve the properties. Here, just the pessimistic scenarios. If it degrades property, how much does it take, how much of the biomass you can push in the material before you actually fall out from this tolerance range, right? For some applications, it will be fairly quickly. For some applications, it may be actually very slow decline. The governing and standard agencies, I think you may be more familiar with those than myself, right? But we need to meet standards set by Federal Highway Administration, AASHTO, NTP, and others, whatever. And then evaluating costs. I mean, this is we've summarized costs incurred within this project, right? And this entire process seemed to be ridiculously expensive when you do it on small scale and when two rookies actually are engaged in there, right? But this is economy of scale, right? So with this scale, this cost will diminish. And the energy inputs and the costs on each stage needs to be evaluated. This is still work ahead of us. So in the summary, I just remind you that this is work in progress, no solid conclusions yet. We are learning a lot, but we have reasons to be optimistic about this thing. And again, the beauty of this idea is that it touches a large variety of products that are prone for, or how to say, or permit manufacturing on very small scale in dispersed manner, right, here and there, tap on very dispersed biomass base and cater to very dispersed usage, right? And it seems to address simultaneously a set of issues public agencies are responsible for anyways. So at this point, I would invite questions, or actually I would have questions to you. I mean, what do you, people intimately familiar with transportation, what do you think about it, right? You have very different pair of glasses to look at the same problem, right? And perhaps you could help us get out of our box and see things in a richer, better way. Yes.
Well, I see that this is a really complicated issue, and I want to thank you guys for doing so much work. From an ecological point of view, though, I think that there's a problem I see with looking at the slash and the materials as being a problem and a waste product, because in the environment they all have a very important function, and the difference between like the eastern forest and the western forest, dry and wet, you have a lot less biomass and a lot less soil build up in the eastern side and a lot more on the western side. So all of it is useful because all of the millions of fungi and microorganisms live in there. And my question was, would it not be possible to do something as they do in sports turf, which is when they harvest the area, chip it on site rather than burning it and releasing all that carbon into the air, and top dress the area and just let it be. And then you don't have to transport it and have all kinds of other carbon footprint issues with more manufacturing, transport, etc.
Thank you. That's a very good question. And as I mentioned earlier in the presentation, we struggle with this a little bit. But on the other hand, this is all true if not for the disruption that happened in this natural process about 100 years ago, when the state agencies decided that no forest fire should be tolerated, right, and suppressed all fires. So because of this disruption, you have very unnatural state of matter particularly in the western forests, right? And this calls for some kind of solution. All kind of solutions seem to be expensive. So looking for ways to find economical way of disposing of this biomass, of this excessive biomass, right, seem to have some track. I've been talking to local communities about it, and they feel the pinch, right, for the times where they could simply use some of the costs from some of the revenues from logging, right, to offset this cost. It's been, well, fine, right? It would still be expensive. Now there is almost no logging going on, and we have no ways of knowing whether we are at the bottom from which we are going to bounce back, or we are at the bottom that is new normal, right? And perhaps some of this forest product operations will never return. Perhaps the level of logging will never return, and still this forest will have to be cleaned from this clogging fuel, right? I don't know.
As you look at replacing some of the plastic with these biocomposites, how would that affect the recyclability of those products when they get to their end of life?
They are recyclable to a certain extent. I mean, you can grind up and reconstitute with plastics pretty much the same way you can grind up and reconstitute plastics. The quality of the material is going to degrade more rapidly than we need plastics. But then you can imagine again with this hierarchy of products, right? Building a hierarchy of how do you use the recycled material, right? And the end product may be just the sound barriers, which do not bear much of structural responsibility, right? The only function, or the primary function, would be damping the noise, right? Yes, please.
I think it sounds really exciting, especially I think that it would be good for you guys to also look more at pedestrian and bicycle applications of infrastructure applications, since those are already like ecologically forward-thinking methods of transportation. I think those industries would probably be really interested in using this product.
That's a great comment, and actually this is something that I forgot to mention. I mean, this may have flashed on one slide. I mean, generally we have focused on highway-related infrastructure as a model for public infrastructure, right? The key component here is just that this is the same entity that is responsible for those forests, for jobs, and for the infrastructure, right? And highway system is just one of them. But this could be bike-related, right, infrastructure. This could be pedestrian paths. This could be anything you could imagine, right? Within public domain, where the same entity is bearing the costs and balancing the charts, right? Thanks. That's a very good comment. Yes.
My question kind of piggybacks off of hers. Has there been any look on applications of biomass in certain forms of paving, whether it's a small percentage like either low volume roads that are paved or weight restricted roads, or even sidewalks as asphalt and as petroleum products start to go up, if there's any percentage of biomass that can be incorporated that still will meet the threshold of integrity?
I'm not very familiar with this line of research, but I know that something like this has been researched in the past and has not been deemed very successful. It may be worth looking at it again in the new context, but there have been talk of mixing this with the bitumic mass and just using it with pavements, it has not been very successful. Yes, please.
Has there been any study of any products being used for water runoff, or any plastics used to channel the wastewater off the roads? Or
Yes, that has been on the list of the. I mean, we are looking at it not specifically because because of the limitation of fundings, right? We had to focus just on few products. But if you look at this list, you would have. Where is it? Drainage, right? How do you call it? Culverts, right? Yes, we've discussed this with Oregon DOT Sustainability Office. That's another potential area, right? These are currently being made of metal or neat plastic, right? So for those made of neat plastic, you just need to alter the technology just a little bit, adding the filler. Still, it needs some research. I mean, how does it interact with water, right, on the constant basis? And but yes, it's definitely a potential. Yes, please, Jennifer.
From a material science or manufacturing standpoint, what is the, I guess, the main hurdle that has to be overcome for these biomass plastics to become more prevalent, or is it more of just a contractor and public agency acceptance issue?
Well, part of this is just what you said. It's the perception and acceptance issue, right? Well, perception becomes reality, right? Because it affects the market, but it's also something that can be changed. More important is because of the diversity of the products, right? Each and every of them would pose, and actually each and every component of this product would pose its own challenges, right? It would have to respond to different, from material science point of view, right? Material engineering points of view, will pose the unique challenges, unique set of requirements, right? Like many of these features have the anchor that is made of different material, that the thing that you see above the ground, right? Well, for this anchor, UV exposure won't be any problem at all, right? Ground contact, oh yes, right? Color, not important, right? For the above ground thing, I mean, well, if this is not the same part that sits in the ground contact for this one is not going to be a big problem, right? Rain exposure, yes. UV exposure, yes. Impact, yes, right? So this is why this entire algorithm, so to speak, right, procedure for looking at individual products, individual parts has been put together, because this is a challenge. I cannot answer this question for the entire group of products at once, right? What is going to be the greatest challenge? For sure, for most of them, the perception, as you said, is going to be a challenge. But what's your perception of 15 or 10% of ethanol in your gasoline, right?
I don't have one.
Right. But see, these are things that are not essentially driven by perception. It's just policy in certain states, right? And they do it. Some people squeak, some people don't, right? There is some science behind it. Some people object the science, and I predict that it may be similar discussion here, although this may be easier because this does not affect every driver the same way as 10-15% of ethanol if they're in the gasoline, right? So if this could be done, if states could have percentage of ethanol in people's gasoline, I think this should be much easier sell.
So we're at our time up, and I have some questions that came in over the web, so I'm going to ask at least one of them to give those folks a shot. And then the students who weren't able to ask their question, write it down, hand it in to me. And those of you who did ask it orally, check in with me. So one of the ones on the web was asking about, are there other states or other countries that are looking into this or who have already done it, or are you groundbreaking in this area?
Yes and no. I mean, I am aware of Weyerhaeuser looking at certain products. They are specifically looking at the guardrail posts, but they are making them of knit plastics, right now. And in perspective, they want to add fillers to it. So we are definitely not alone, right? I'm not aware specifically of things going on in other countries. Although, again, just as the wood plastics may be, just like highway products may be example of larger group of products. Wood plastics may be just example of larger group of bio-based composites, right? And you can definitely see guardrails being made of either solid wood or wood, some kind of wood composites, right, in other countries. So I wouldn't claim that we are, at the spearhead of this entire movement, right? We just try to look at it in a little broader perspective and try to tackle it in a way that would address the complexity of the issue rather than just single products.
Okay, before we thank Lech for expanding the diversity of our transportation seminar, next week's speaker is Eric Dumbo. He's an assistant professor at Texas A&M University. He's going to be talking about safety and planning, and he's an OTREC visiting scholar. So with that, I'd like to thank Lech for his presentation today.
Thank you very much. Thank you. I would really, if you